Alright, so we're going to do number 2. And that's all about the motorboat pulling an 85 kilogram skier. Alright, so we've got the force of friction on the skier is 550 newtons. And the motor is providing an applied force of 1500 newtons. Now the trick, or not the trick, but the important key words for this question is that it's a constant velocity. Alright, so we're not going to be accelerating. So what do we know about the net force acting on the system if it's constant velocity? Oh, nice. What'd you say? It's 0. Good. Okay, so V is constant. Okay, so the net force is 0. Okay, so that's all the information we can pull out of that before we get into the questions. Part A says describe the action-reaction pair that causes the boat to move forward. Alright, so think about it. This has nothing to do with the math. This is just thinking about a boat. How does a boat move through the water? Motor spins the propeller, yeah, which pushes against the water, and the water pushes back against the propeller. Okay, so that's your action-reaction pair. Part B says draw free body diagrams for the skier and the boat. Okay, individually, it's pretty straightforward. I believe enough room up there. Okay, for the skier, we've got force of gravity and the normal force. We can calculate that, but I don't think we need to at this point because there's no acceleration in the vertical sense. So we're just going to leave it like that. So the force of friction to the left is 500 newtons. So what's the force that's causing the skier to, or pulling the skier to the right? Applied force. Let's be a little more specific. It is an applied force. What's he holding on to? Okay, so when we're talking about ropes, what do we usually call the applied force? Yeah, tension. Good. And since the skier is not accelerating, what do we know about the force of tension? It's constant, yes, but it's equal to friction. Yeah. Yeah, we just don't need to calculate. You're right. It would be, but we don't really need to calculate for this question. Okay. All right, so this is the skier. Now we need the boat. Again, we've got Fn and Fg, but we don't need to calculate those values at all. So we've got two forces counteracting the boat's motion, or the boat's applied force. Which one of them, Stephen?
Tension.
Good. Tension. The equal and opposite tension that's on the that's acting on the skier. And even though it doesn't tell you in the question, there still is friction acting on the boat. And the reason I know that is because if we go back up here, F net has to equal 0, so the total friction has to be more than 550 newtons, or else there would be an acceleration. Okay, so what do we got here? FF. Let's call this FF1, and we'll call this FF2 because they're not the same thing. One's acting on the boat, one's acting on the skier. Yeah, so 950. Yeah, that's right. Okay, because you want the net force to be 0, so whatever forces we have in the forward direction have to be counteracted and canceled out by the forces in the backwards, or the opposing forces. Any questions so far?
So they're equal because of the constant velocity.
That's right, yeah. Constant velocity means all forces for all the objects have to be canceled out. Alright, I think in this case we've actually answered questions D and E as well. Oh, C. Yeah, we've answered C, D, and E all the way through. So C, since constant velocity means 0 acceleration. Question D, the tension in the rope we already calculated is 550 newtons. Okay, because it was equal to the force of friction acting on the sphere. And the force of friction on the boat and that's because force of friction on the boat plus the tension had to be equal to and opposite the applied force. Yeah.
Sorry, why was the tension equal to the friction again? For the skier?
Why was the because it's moving. The skier is moving at a constant velocity along the boat. That's right. That force has to be 0. Now, if I'm being really thorough here, I should put negatives on these, just because this is moving to the left and this one's moving to the right. And question F. Okay, so now we're actually going into the realm of acceleration. So now instead of the force being 1,500 newtons, now the friction force remains the same, but the boat increases its thrust to 1,700 newtons. Hi. I'm recording a video right now, and you just ruined it. I'm just kidding. You didn't ruin it. Are you staying?
Well, I'm going to collect any notes for Lola here.
Okay. All right. Okay, so now we've got. Look at the system as a whole again. Now we've got an FA of 1,700 newtons and a frictional force of 1,500 newtons. Okay, so what's the net force acting on the system? Tune back in here, guys. I know I lost you. Okay, so now instead of moving at a constant velocity, The boat's accelerating it's increasing its force to accelerate. Yeah,
Yes, 200.
yeah,
Okay.
straightforward, right? 1700 minus 1500. And I think do they give us the? Oh, they give us the acceleration. They want to find the mass of the boat. All right. So also given A is equal to 0.54. Hi. I just gave them to Christy. I think she has yours. Yes. Alright, so we can use Newton's second law. So what do we get there? 200. Oh, we'll probably get more than 285 because that includes the sphere. So the total mass is. What do we get for that answer? 390? 370, I can't. Yeah, 370 kilograms. So that's the mass of the boat plus skier. So if we subtract the skier's mass, we end up with 285 kilograms. And that's our final answer. Question? Sure? You'll get on YouTube if you ask questions. Okay. Enzo? Hey.
Just the boat, or did we have to calculate as like an overall system?
Say that again?
Like, can we assume the open boat, like how you mentioned, like, you know, like the same object, or do you have to do the whole thing as well?
If they were asking for the tension, then you'd want to zoom in on the boat.
Okay.
But the last question here, they weren't asking for the tension, just the overall mass.
So if F net equals AM, the only point is here.
F net equal for and Fg is equal to mg
It's mg mass
times the gravitational constant, 9.81. Yep. Mm-hmm.
times.